Okay, so here's the second example. Again, this is going to be a degenerate conic, but we don't know which one until we start working it. You might, when you look at this, you'd see an x squared minus a y squared, so you should be thinking that it's probably going to be a hyperbola. But a degenerate hyperbola is going to kind of be two intersecting lines. So this is going to be the example, two intersecting lines, but let's pretend we don't know that. X squared minus 6x, leave a space, minus y squared plus 2y, leave a space, equals -8. Now this is a 1, but this negative here needs, this negative in front of the y squared needs to be handled, so let's just go one more step. Factor out a negative, leaves me y squared minus 2y, leave a space. Okay, so we're going to complete the square here. Half of 3 is, so add 9, half of 2 is 1, squared is 1, add 1, but we're actually adding -1 times +1, so it's a subtracting 1, so subtract 1. So here we got x minus 3 squared minus y minus 1 squared equals, and again you should kind of see that something strange is going to happen because I get a 0 on the other side. When you get a 0 on the other side, that's when you get a degenerate conic. But this isn't going to be a point solution because there's a lot of numbers that you can put into here that whenever you square it and get a positive number, then you subtract this positive square that you get 0. So it's not going to have just a single solution. The center of this would-be hyperbola is the point 3,1. I think we're going to see that that is a kind of a special point. So let's just manipulate this thing. Let's go x minus 3 squared equals, let's move this over to the other side, y minus 1 squared. So if I want to solve this for x or y, I guess let's solve it for y, see if it's not a function, but let's solve it for y. Square root both sides, but you got to put plus or minus somewhere. I'm going to put the plus or minus here. So now I have y minus 1 equals plus or minus x minus 3. Well, this is two different equations. This is y minus 1 equals positive x minus 3, or whatever, y minus 1 equals negative x minus 3. So this is y minus 1. Normally I would solve these for y and kind of put them in y equals mx plus b form, but if you kind of look at them this way, 1 x minus, my pen's not working, sorry, x minus 3, or y minus 1 equals -1 x minus 3. These are in point slope form. This line is a line that has a slope of 1 and goes through the point 3, 1. This is a line whose slope is -1 and goes through the point 3, 1. And notice those points is where the center of that hyperbola would have been. So if you leave them in this form, I guess we can just kind of go through the point 3, 1 and then draw off one line that has a slope of 1. I wish I could do those a little better, but I guess I'll just, that's pretty good. And then the other one has a slope of -1, so, oh, it's a little wiggly. Now, if you wanted to, if you didn't want to leave it in point slope form, you could solve this equation for y, and I'm willing to bet that you're going to get y equals, you're going to get negative x, and this is the one that's got a negative slope, so it's probably going to be a plus 4 y-intercept. And if you solve this one, you're probably going to get y equals x minus 2, and that's because that's where that one crosses. So you can simplify those and graph them separately, but it's going to be two intersecting lines whose center meet at that point that is a center. And by the way, if this was a hyperbola, and if this number here wasn't 0, these would be the equations of the asymptotes of that hyperbola. The hyperbola would kind of look like this or something, or maybe like this or whatever. But it's not a hyperbola. It's the two intersecting lines. All right, so that's the second degenerate conic. Stop. Stop.